Okay, so we are going to solve this question I have on the screen here, which says that in the circuit below, the 10 volt Zener diode can maintain regulation over a range of current values from 4 milliampere to 40 milliampere. Calculate the range of input voltage for which the diode can maintain the regulated output. Okay, so you see that the Zener diode is rated to be a 10 volt Zener diode, and then it can maintain this 10 volts over a current values ranging from 4 milliampere to 40 milliampere. So you should calculate the range of the input voltage for which the diode can maintain the regulated output. So you should calculate the range of input voltage, okay, which will still cause the Zener diode here to maintain this 10 volts here, giving this resistor value to be 1 kilo ohm. Okay, so in this case the voltage source is varying. Okay, the voltage source is varying, so you are going to find the input range, okay, which will still help the Zener diode to maintain this 10 volt output here. Okay, so in this circuit here, it's just the same as a normal circuit where you have this side closed. Okay, so in this case we use the ground connection here, so it is connected to the ground. It's just the same as we connecting this side to this side. Okay, so you know that in this circuit the total voltage will be, that's voltage from the source V in, will be equal to the voltage drop across the resistor, which is VR plus VZ, which is the voltage across the Zener diode. Okay, so for us to be able to get the V in, we will need VR and then VZ. But in this case, VZ is given to be 10 volts. Okay, that means no matter the power from the source, no matter the voltage from the source, the Zener diode those two have a voltage drop of 10 volts. So that's constant. So that will be equal to VR plus 10 volts. Okay, so now what you need here is VR, which is the voltage across the resistor. Okay, which is the voltage across the resistor. So how do you find the voltage across the resistor? So the voltage across the resistor would be equal to the current across the resistor times the resistance. But in this case, the resistance is given to be 1 kilo ohm, so that would be times 1000. Okay, that's 1 times 10 to the power 3. So now what you need is IR, which is the current through the resistor. So I'm going to find the current here. So in this case, you see that this side of the circuit is open, so that means current doesn't flow through it. So when current gets to this node, it will flow back into the Zener diode. So that's to see that the current through the Zener diode is the same as the current is the same as the current through the resistor here. Okay, so first of all, we are going to find the minimum voltage input. Okay, because we have to find the regulated the input voltage range. Okay, so you are going to first you are going to find the minimum voltage. So this will be the minimum input voltage, the minimum input voltage. Okay, so that's what you are finding now. Okay, so for us to find the minimum voltage, the minimum input voltage, we need VR. So that's what you are working out on here. Okay, so for us to get VR, we are going to use the minimum current in the Zener diode here. Okay, so when we use the minimum current in the Zener diode here, that will help us get VR here, and then we can use that VR to solve for the minimum input voltage. So we already know that the Zener diode is in series with this resistor, so that means the same current will flow through there since this side is open. Okay, so when the current of 4 milliampere is flowing through the Zener diode, that same 4 milliampere will flow through the resistor here. So what will then be the voltage drop across this resistor? So that will be 400 milliampere. That's 400 times 10 to the power minus 3 times 1 times 10 to the power 3. So let's see what we get for that. So 4 times 10 to the power minus 3 times 1 times 10 to the power 3. So that gave me the voltage value to be 4 volts. So that means VR will now become 4 volts when the current flowing through it is 4 milliampere. Okay, so since we now know VR, let's come and substitute it here. So that will be 4 plus 10, so that will be equal to 14 volts. So this will be the minimum input voltage. Okay, so now that you know the minimum input voltage, we used the minimum current flowing through the Zener diode to solve for the current in the to solve for the voltage in the resistor here. So we are going to use the maximum one to solve for the for the voltage in the resistor. Then come and add it to Vz, and that will help us to find the maximum voltage input. Okay, so let's do that one also. So for maximum input voltage, that will be V in will be equal to VR plus Vz, right? So we don't know VR yet, but I know that Vz is always 10. Okay, so now let's find VR. So in this case, you are going to find VR using the maximum current in the Zener diode. Okay, we're going to find VR using the maximum current in the Zener diode. So VR will be equal to 40 milliampere, okay, times the resistance value, which is 1 times 10 to the power 3, which is 1 kilo ohm. So let's find the value of what VR. So VR will now be 40 times 10 to the power minus 3 times 10 to the power minus 2. So that will be 40. Okay, 10 to the power minus 3 times 10 to the power 3. So that will give me 40 volts. Okay, so that will be VR in this case. So you just come and substitute our 40 volt here, then plus 10. So therefore we get the maximum input voltage to be what? 50 volts. Okay, so now we were asked to find the range. So therefore the range will be from 14 volts to 50 volts.